Here we are at the bottom of page 12, middle of page 12, and we're going to solve the following equations using the completing the square. The first few are already set up like that, so it looks nice. So here we go with number 17. X plus 4 squared equals 25. And the whole idea here is that we're going to undo squared with a square root. Don't forget to put a little plus or minus in there. So we get x plus 4 squared, square root, undo each other, and we get plus or minus. That is a 5. So then when we subtract 4, a negative 4 plus or minus 5, negative 4 plus 5 is 1, and negative 4 minus 5 is negative 9. So we get two answers to this problem. And you can check them both. If you stick 1 up here, 1 plus 4 squared, 1 plus 4 is 5, squared is 25, works. Negative 9 plus 4 is negative 5, squared is also 25. Number 18, x minus 6 squared equals 7. Again, undo that with a square root, make sure we get the positive and the negative on the square root so that both of them will work. X minus 6 equals plus or minus square root of 7, add 6 here, add 6 there, and we get x equals 6, positive 6, plus or minus the square root of 7. And if you stick that in your calculator, the square root of 7 is, 2 point something, and probably about 2.7, 2.6, something like that. So these answers are going to be about 8.6 and 3.4, something like that. Those are two answers, and they're in exact form. Number 19. Here we have this. Let's just skip to the part where we just square root and square root with a plus or minus, and we get x minus 5 equals plus or minus square root of 12. Now square root of 12 can simplify. This breaks up into 4 times 3, and the square root of 4, well, that's something we know. That's 2 square roots of 3. So we actually have plus or minus 2 square roots of 3 here. And then when we add 5 to both sides to get x by itself, we now have x equals 5 plus 2 square roots of 3 and 5 minus 2 square roots of 3. And those are our two answers. So this plus or minus kind of gives us those two answers there. Number 20. X plus 2 squared equals a negative 9. So if we square root both sides, and put a plus or minus there, we now have x plus 2 equals, now the square root of negative 9 is going to be 3i. So it's x plus 2 equals plus or minus 3i. If we subtract 2 from both sides, we have x equals a negative 2 plus 3i, negative 2 minus 3i. And this actually brings us to a good point. Anytime you see imaginary or these square roots showing up in answers, that they always come in conjugates. 6 plus the square root of 7, 6 minus the square root of 7. Negative 2 plus 3i, negative 2 minus 3i. That's just a really good pattern to identify and keep in mind. 21. Here we have a square root on both sides here, and we get a plus or a minus. And good, so we get x minus 7 equals, now 8 breaks up into 4 times 2. So that's going to be 2 comes out of the square root for the square root of 4. And then the negative brings an I out, and you have a square root of 2 plus or minus. So 8 would have been 2 square roots of 2, and the I is with the negative. So now we add 7 to both sides. And we get x equals 7 plus or minus 2i square roots of 2. Or if you wanted to write it in the standard form, it would be 2 square roots of 2i. But some people get a little confused as to whether the I is under the square root sign or not, so I'm going to put a space there. Number 22. Now this one, you'll notice that all of these were perfect squares, and it's really nice to get them into perfect squares, and the answers come out pretty easily. Here, we could rewrite this guy as a perfect square. You'll notice that this is 4 doubled, and that's 4 squared. So this is actually written as x squared Nope, not x squared. X minus 4 altogether squared that equals 5. So that guy is x minus 4 squared. And be able to recognize that is kind of tricky, but it's kind of nice when it happens. So now we can square root and square root just like we've done. We have x minus 4 equals plus or minus the square root of 5. Add 4 to both sides, and we have 4 plus or minus the square root of 5. All right, for these last ones, this is going to be a little bit trickier. We're going to start up here with number 23. Oh, this one's not so bad. This is double 9, and this is 9 squared. So this is going to be x plus 9 altogether squared equals a negative 3. So we square root and square root, plus or minus. We have x plus 9 equals plus or minus I comes out, and we're left with square root of 3. Or you could write square root of 3i. Subtract 9 from both sides, and we get x equals negative 9 plus or minus I square root of 3. Or square root of 3i, if you would so choose. Number 24. Ooh, let's see if this one's a perfect square. Half of 6 is 3. That's not a 9. So that guy's in the way. So this is really the key of completing the square, is that we could get rid of this guy and take him over to the other side and have x squared minus 6x equals a negative 13. Now what we do is we say, what number do we want there? We wanted a 9 there. So we put him in there, add him to the other side, and now we have a perfect square. X minus 3 squared equals negative 13 plus 9. That's a negative 4. And now it's set up so we can do it nice and quick. Square root, and we get x minus 3 equals square root of 4 is 2. Square root of a negative is an I, so we get 2i. Oop, plus or minus, don't forget that guy. We get x equals 3 plus or minus 2i. And then we have number 25. Same thing happens here. That 16 is in our way. Let's get rid of him over there. So we write x squared minus 10x. Leave a space for a good number there. Equals negative 16. And what number do we want? Half of that is 5 squared. So if we add 25 to both sides. Now if you note up here, we could have added 9 to both sides early on. But either way, this becomes x minus 5 squared equals 25 minus 16 is 9. And it's in a format that we can just square root and continue on. It's kind of nice. Plus or minus, we get x equals, add 5 over there, 5 plus or minus the square root of 9 is 3, which means we get x equals 8 and x equals 2. Look, we got one that came out just right. Now I want to show you this one because it's kind of nice that it came out really well, that this one actually could have been done by factoring. If you were to factor this guy, you'd have x minus 8, x minus 2, which would get you x equals 2, x equals 8. So you still get the same answers no matter what. However, these guys, the one with the square roots and the imaginary numbers, would not have factored into nice normal numbers that we know.